Right now, highly capable professionals are working harder to achieve less. We have a workforce holding advanced STEM degrees, yet they face intense cost of living pressures, mounting debt, and a job market that often underutilizes their actual expertise. This is the result of an economy operating on probabilistic systems. It creates a high-competition, low-leverage environment where you can expend a massive amount of personal energy, but the structure of the system no longer guarantees a stable, predictable outcome for your effort. This structural flaw is mirrored in our digital infrastructure. The large-scale artificial intelligence systems currently dominating the market suffer from an identical kind of friction. Current AI models scale by brute force, relying on statistical approximations. As these systems process more data over longer horizons, the computational friction builds until the logic begins to hallucinate, diverge, or lose coherence under its own weight. Both our economy and our digital infrastructure are drifting under load. Replacing these systems requires a deterministic foundation, a substrate where information is never lost and outcomes are mathematically guaranteed. Oikonomia Architektur has engineered a frontier computational substrate built on a reversible transport primitive. This architecture replaces probabilistic approximation with deterministic geometry-native computation. Instead of relying on energy-intensive consensus, this system processes information using a reproducible geometric law. In hardware testing, this operator maintained world-state consistency across a 100 million token ledger with zero semantic drift and a constant memory footprint. When applied to digital settlements, this stability replaces slow reconciliation with instant physics-rooted validation. Financial state transitions are computed deterministically, ensuring that trust is generated by the structure of the computation itself rather than energy expenditure. This stability scales because the underlying operator is a law of reversible transport. Whether the system is moving symbolic data or physical coordinates in a 3D field, the same geometric update law preserves the structure of the information as it evolves through time. We see this in the drone control primitive. By replacing traditional predictive loops with this multi-scale update law, the aircraft achieves instant attitude changes. It snaps into an inverted hold with mechanical precision and zero wobble. The same mathematical architecture functions as a computational metasurface for energy. By applying the fractal update law to light transport, the system traps photons algorithmically, increasing the efficiency of solar capture at a planetary scale without requiring new chemical materials. From stabilizing drone physics to verifying global financial ledgers, this computational primitive delivers structural predictability to an unpredictable world. Managing systems of this scale, autonomous ocean platforms and global digital settlements, creates a specific operational requirement. These high-stakes environments cannot be safely left to pure automation. Oikonomia's enterprise licensing architecture reflects this reality. Embedding this deterministic technology into critical infrastructure strictly mandates specialized human oversight to manage the system's stability. While many AI models are designed to automate human roles, deterministic infrastructure creates a demand for high-level analytical talent to oversee the hardware. Stable infrastructure requires human intelligence as the ultimate failsafe. By tying a technological breakthrough to human validation, the architecture functions as a driver for new economic roles. This shift introduces new categories of work, such as the scaling analyst. These professionals utilize analytical models to forecast deterministic hardware efficiency and operational costs before large-scale simulations begin. Validation specialists and domain operators represent a second tier, overseeing hardware invariants and managing the complex parameters of drone fleets, energy grids, and settlement systems. For the workforce currently facing underutilization, this creates a proprietary moat. It offers a professional environment that utilizes the rigorous analytical skills from their advanced STEM training. Because human validation is built into the technology's licensing, this translates to stable income, granting the structural leverage missing from the probabilistic economy. The deployment of a specialized American capability layer integrates this intelligence into the national infrastructure, from energy grids to aerospace control. Economic relief is found in the deployment of deterministic frontier infrastructure. It restores clarity and leverage to the worker by replacing drift with a foundation built for long-term reliability.